Okay, so hello everyone, I'm Spanj, and this is according to an assignment which is given to us to understand the difference between MLP, GRU, LSTM. I'm recording it for the second time. The first time something in my screen recorder broke and it didn't implement it perfectly. So, firstly, if I just give you just about what a time series data is, so basically it is something in which the next step is dependent on a previous step in layman terms. So what happens in the time series data is it is all connected. So the next output also depends on the previous output. Like something which happened on 12 Jan, something which happened on 13 Jan, something which happened on 14 Jan, like electricity usage, credit card usage, money spent to buy something for a particular person, etc. etc. So all these come in time series data. Now the current problem with MLPs and other technologies out there is they don't consider the fact that we can have an existing memory. So if something is having an existing memory, the MLP doesn't consider it. So we are trying to identify how that could be improved and what all are we doing here. So basically, let me first explain what all I've used. So firstly, there is this data set which I've took from Kaggle as mentioned in the assignment. Secondly, is this uh, a data set, which is a manual synthetic data set due to the constraint of time. So I use this. Uh, this assignment also involved me showing my roll number and the window size, which came out to be 16, the prediction horizon, which came out to be 1, the hidden size, which came out to be 14. So these all are dependent on my roll number and will change from person to person. So here we are trying to make the windows. So we are trying to take 16 windows and trying to skip one or two and then coming back. So sort of make a window and time series type of frame here. Next is our class MLP. So what you will see is it is taking the complete 16 windows as it is. And we have also experimented with half the window size, double the window size. I'll get back to that later. So this is a basic MLP. This is a GRU. We haven't used any library like out of the box. It is made from our GR. So let me first explain a bit about GRU and LSTM. Now what LSTM does is better than MLP. It has a memory layer. So it has three gates, a input gate, a forget gate, and output gate. GRU has only two gates. It is better in computation wise as compared to an LSTM. What GRU has, we have this reset gate and we have this forward gate. So both we are using sigmoid function here. Then we have used the tan h computation to calculate the next one. So this is our GRU. This is our LSTM as well. So what we are trying to do here is create compare these along with an LSTM and with a transformer as well. Here we are trying to train the model on the given data. Let's see what all outputs are coming, what all losses we are getting. uh, we are trying to predict, and here we are trying to compare that what all we got here. We have used Adam optimization here, if I forgot to mention that. So yeah, that's how it is working here. Now let me come and show you the output as well. So just give me a second. This is what I got as an output. So if I consider like the current window size was most optimal, if I half this or double those, the outputs changed a bit. For the air passengers one, although it was a synthetic data set, that's why you can see that our GRU failed a bit, our LSTM failed a lot. But for the electric prediction data, which was a bit good as compared to the air data set, uh, here LSTM and GRU, they were better than, like, in performance wise, as compared to others. Now, what other thing which we have is here is we have a results, what we say, photo. So it is explaining and showing us different losses. What are the loss for transformer? What are there for LSTM, for electricity? So it shows. Now there is a reason why this model looks to fail in certain areas, that's because we have trained it on a lesser data and on much less epochs. If I would have trained it on a larger data set and a larger number of epochs, then obviously it would have worked better. GRU and LSTM, all these are better than MLP because they persist the memory rather than just keep on going on the previous data set and forgetting what happened in each layer. So that's the gist of it. I'll attach this link as well so you guys can know what all worked and what all not worked, and you can try it out as well. So yeah, that's it from my side. Here is this graph which you can see loss compared to transformer LSTM. This is for air pass, and I guess this is for electricity. So yeah, that's it from